Hi everyone, good afternoon. Good afternoon everyone. Here we'll be starting. Okay, right. I think it is visible, audible and visible, everything, I think so.
He's got on the wrong foot here.
Right. Myself, all of you know, myself Rajendra Prasad. People call me RP sir generally. These are all the subjects I'll be taking in Unacademy Plus platform. Transportation, steel structures, high OJS, structure analysis, RCCPSC, surveying, engineering, design and drawing. These are all the subjects I'll be taking. Whenever you are subscribing for the plus courses, don't forget to use this code RP Civil. Okay. Now, this is our faculty team: RP sir, myself, KP sir, and AR sir. We three together will be teaching in English language. We three together will be teaching in English language for GATE and ESE plus courses. Right? KP sir will be taking these subjects. RP sir, myself will be taking these subjects, and Abdul Hafiz sir will be taking, AR sir will be taking only geotechnical. So the most important announcement, there is a price hike, right, from today midnight. Okay, so from today midnight means what? From today midnight means it will be from 12 o'clock midnight today, that is 20th onwards. There will be going to price, the price is going to be increased. So before it is getting increased, utilize that opportunity of subscription for lower fees. Use the code RP Civil and get the subscription, you can say. Okay. Good afternoon, Deepak Kumar. Right. These are all the courses I'll be taking in Unacademy Plus platform. These are all the courses I have completed already, and these are also completed. And the crash course on transportation engineering will be starting from 21st November, and the complete course on reinforced concrete structures, it will be starting on which one? 17th October. It was already started on 17th October. It will go up to 17th November, you can say. Okay. Coming to this reinforced concrete structures complete course, 17th October to 17th November. Every day the class timings will be 5:30 p.m. to 7:30 p.m. So these are all the contents I am going to be discussing there. Except that masonry structures and earthquake resistant design, I'll be covering all these topics. Okay. Now, when anybody is subscribing for the plus courses in Unacademy learning app, don't forget to use this code RP Civil. Then only you will be getting these are all the benefits, right? So by today itself, most of you try to subscribe for the plus courses, because from today midnight onwards, the price is going to be increased. Okay, these are all the classes, right? This red color one are YouTube classes. These are your Unacademy classes. Again, I am telling, price hike alert. Price hike alert. Okay, you have to be careful. Now, MSQs, and coming to this MSQs on this highway engineering. MSQs on highway engineering, we'll see on 21st MSQs on railway, on 23rd MSQs on airport, we'll see. Don't worry. So now this is the first question. Let us say, which of the following are the reasons for initial concavity of load deflection curve of CBR test? Whenever we are going for the load deflection curve of the CBR test, in that load deflection curve of the CBR test, there is an initial concavity you are getting. What is the main reason for this initial concavity? I think that is not visible. Just a minute. Yes. So initial concavity of load deflection curve of the CBR test, right? Generally, how the load deflection curve must be there? If you just observe, this is your cylinder, and we are having a plunger like this. Okay, by means of this plunger we are applying the load. We are applying the load onto this soil CBR to get the CBR value of the soil. Now when you are applying it, what are the reasons, right? If you just observe the load deflection curve, this is your P, this is your delta, so it will be like this. Generally, as the load increases, deflection also increases, right? Load increases, deflection also increases, right? Abhishek, good afternoon, how are you? Right, so the load deflection curve must be of this shape, right? Load deflection curve must be of this shape. But sometimes what we are having, we will be having the load deflection curve in this manner. In which manner you will be having the load deflection curve? If you just observe, initial concavity you are getting, after that the curve is convex again. This is your load and this is your deflection. So what it indicates, if you just observe, it indicates that even for small amount of load also we are getting larger deformation, right? The deformation part is larger even for small amount of load also. That too in the starting of the loading conditions, the soil will be having higher strength. So it must be what? To create even small deflection also we should require larger load. That is correct. Convexity fully is correct, right? First curve is correct. But if you are getting the second curve like this, means initially concave portion we are getting, means what does it mean? Even for smaller load also we are getting larger deformation. Means it is not the behavior of the soil actually. It is not the behavior of the soil actually, right? It is not the behavior of the soil actually. Then what we need to do? We have to modify this curve, right? How to modify this curve? Where the first point of convexity is there, draw a tangent, and this particular point will be taken as a new origin, and from this point onwards, right, up to this first point of convexity, you consider this straight line portion. Next you consider the original curved portion, right? This is O dash, you can say, right? This is O. So previously origin was here, but we are shifting it to O dash location, you can say, right? And what are the different reasons for this? Suppose if you are having the surface undulations of the soil, when you are having the surface undulations of the soil like this, what will happen? First, what it will do? It will try to make it uniform or not? Yes, obviously it will try to make it what? Uniform, right? Obviously it will try to make it uniform. In the process of uniform, these voids will be filled completely. So this portion will come here. So this is a displacement, or it is just the adjustment of soil, you can say, in the initial stage. In the initial stage, when load is applied, larger deformations you are noting down, but those deformations are due to deflections or those are due to adjustment of the soil here and there? Tell me anyone. Those are due to what? Adjustment of the soil here and there only, right? Those are due to which one? Adjustment of the soil here and there only, right? Adjustment of the soil only. So this is also a reason, right? This also can be a reason. Yes. Now second one, so larger deformations will be having. Once it is getting leveled, what will happen? Then again it will become convex, right? It will become convex, the curve, due to soft soil present at the top. Whenever this soil is soaked in water for 4 days at 90 to 100% of optimum moisture content, there is a possibility that very soft nature of soil will be present at the top or not. Just if you observe the basic example of rains, before rain comes, you keep your foot on the land or earth, you will feel very hard. But once rain comes and goes off, once the entire water goes off, you just try to keep your foot there on the soil. What you can observe? You can observe very smooth or very soft soil. Your leg will be penetrating into the soil easily or not? Yes. The same situation will come here also. So when you are having a soil, if the soaking or mixing is not done proper, there is a possibility that all the soft particles will be floating onto this water and they'll come to the top. So they'll come to the top. When they will come to the top, what will happen? The soft nature, a soft layer of soil will be formed here. When immediately after placing the plunger, it will deflect up to this point easily. But after that, hard soil is there, it will be convex curve. So this also can be the reason or not? Yes, this also can be the reason, you can say, right? Now, inclined position of the plunger. Whenever you are placing the plunger in an inclined position like this, what it will result in? So what will happen? Instead of transferring the load over the entire area, we are just transferring over the tip. We are just transferring over the tip or sharp edge. Because of this sharp edge, what will happen? Penetration will be very, very larger initially or not? Yes. So that is why penetration will be very, very larger even for smaller loads also. Because of this entire load concentration. So inclined position of plunger also will be the reason. Sudden application of the load? No. This is not due to the sudden application of load. If you are applying the load suddenly, do you have any problem? We don't have any problem. So the curve will be suddenly increasing like this. Okay, we'll be getting the curve also suddenly like this, but you don't get initial concavity, right? So which are all the options you can say? Option A is correct, B is correct, and C is correct, right? So is it clear, everyone? All of you, is this clear? Is that point? Is this question clear? Right? Now we'll be moving on to the next part. Which of the following are correct variations of parameters with respect to bitumen content in Marshall stability test? In Marshall stability test, you can say, right? In this Marshall stability test, which of the following are told? First one. First one. So let us consider this curve. On x-axis it is percentage bitumen. On y-axis it is Marshall stability value. If you just observe, the curve is like this. B, Marshall flow value percentage bitumen, like this. Percentage bitumen, Marshall flow value, like this. Notice percentage voids, and it is percentage bitumen. It is like this. Okay, can anyone say which options are correct? Can anyone say which options are correct? Which graphs are correct, all of you? Which graphs are correct? Anyone tell me? Anyone? So here if you just observe, the first graph is correct. Up to the bitumen, up to certain bitumen content, the Marshall stability value. Marshall stability value is nothing but which one? Maximum load taken by the specimen at the time of failure, right? Maximum load taken by the specimen at the time of which one? Failure, right? At the time of which one? Failure, right? At the time of failure, what is the maximum load it can take? That is your Marshall stability value. So as the bitumen content increases, what will happen? The particles will be binded together. When the particles are binded together, obviously what will happen? When the particles are binded together, obviously what will happen? When the particles are binded together, the strength will be increasing further or not? Yes, the strength will be increasing, but up to which point it will be increasing? It may not be increasing continuously. It will be increasing up to certain point only. After that, it may not be increasing further. It will be decreasing beyond the saturation limit. So what is this saturation point you call it as? Optimum bitumen content is taken as a saturation point. That optimum bitumen content will be taken as which one? Saturation point, right? Up to this optimum bitumen content, that Marshall stability value increases, and after that it will be decreasing, right? So the first curve is correct. Now, Marshall flow value, if you just observe, what is that curve? Marshall flow value is nothing but maximum deformation at the time of failure. Marshall flow value is nothing but maximum deformation at the time of failure. So here, as the bitumen content increases, ductility increases, right? As the bitumen content increases, what will happen? Ductility increases. When ductility increases, what we can say? When the ductility increases, deformation at failure, that is Marshall flow value also increases. The Marshall flow value also increases, right? Like that. Marshall flow value also increases, right? So here, it will be directly proportional only. But if you just observe, directly proportional, non-linear only, but whether it is upper curve or lower curve, how can you identify? We just observe. As the bitumen content is increasing, right? As the bitumen content is increasing, even though we are having which one? Bitumen addition, but whose behavior is dominant in the starting for most of the time? Aggregates behavior is dominating. So aggregates behavior is dominating means our ductility or Marshall flow value will be lesser than expected. So lesser than expected means, let us say if this is expected, this is more than expected, this is lesser than expected. So which curve? Our ductility will be lesser than expected means this bottom curve will be correct, you can say. So this bottom curve is correct, B is correct and C is wrong, we can say. Now, percentage air voids and percentage bitumen. As the bitumen increases, what will happen? As the bitumen increases, as the bitumen increases, as the bitumen increases, as the bitumen increases, what will happen to this? Voids will be decreasing, obviously, no? Inversely proportional, right? Inversely proportional. So whenever it is inversely proportional, the curve will be like this. Either it is upper curve or it is lower curve like this. But if you just observe, filling is more than expected. Suppose if you are adding 100 ml bitumen, 100 ml bitumen, it will be spreading for more than 100 ml. Why? Because in the initial stage when you are adding the bitumen, that is in liquid format. That is in which format? A liquid format. So whenever it is a liquid or fluid format, that liquid or fluid will be having expansive nature, you can say, right? That liquid or fluid will be having what? Expansive nature, you can say, right? Whenever there is an expansive nature, automatically volume filling will be higher, right? Volume filling will be higher compared to the voids reduction. So voids reduction is lesser than the expected. Lesser than the expected means lower curve, you can say. So this Marshall stability value already we have mentioned, that means this is wrong. So which options can be correct here now? A, B and D. These three options will be correct, you can say, like that. So is that clear, all of you? Is that clear, all of you? Somebody respond. Somebody respond. Okay, I think it is clear. So next question number 3, if you just observe, right? Here if you just observe, What are the conditions given? Let us say here, right? The jam density for a given flow let us say the jam density is 100 vehicles per kilometer. Free flow speed is 50 kmph. Then maximum flow expected is. So how can you get this maximum flow? We can say, so it is depending upon which one? Here it is depending upon which one? Here it is depending upon which one? The type of model we are using or not? Yes, type of model, right? First one is which one? Based on linear model. What is that linear model? You can say it. Based on linear model equal to how much? 1250 vehicles per kilometer. Next, based on linear model, that much you can say. Based on linear model, that much you can say. Now, what is next one you can say? Based on logarithmic model. Based on logarithmic or exponential model, how much is the maximum flow you can say? 1840 vehicles per hour. Vehicles per which one? Hour you can say, right? Vehicles per hour it is. Now, what is it? You can say based on logarithmic or exponential model, it is how much? 1250 vehicles per hour. Now, based on linear model, it is equal to 1840 vehicles per hour, like that. So this is a question you can say, right? This is the question you can say, right? Whenever it is a linear model or green shield model, anybody remembered what is that maximum flow? For linear model, what is that Q maximum? If you remember, Q maximum equal to Kj by 2 into Vf by 2. What is that Kj given? Jam density is given as 100 vehicles per kilometer divided by 2 into Vf by 2, free flow speed by 2. What is that free flow speed given? 50 kmph is the free flow speed Vf given. Kj is jam density, Vf is the free flow speed divided by 2. So what is that value? Vf is given how much? 50. So how much it comes to be totally? 1250 vehicles per which one? Hour. 1250 vehicles per what? Hour you can say, right? And when it is exponential model, Q maximum equal to what? Kj into Vf by E. Or when it is logarithmic model, that Q maximum is given as what? Kj by E into Vf. Both are same only or not? Exponential model and logarithmic model both are giving same value only or not? Kj into Vf by E, right? Kj is 100 into Vf is 50 divided by E value. How much you are getting now? Here if you just observe, how much you are getting if you just observe? 1839.4 vehicles per hour. So which one is correct now? Based on the linear model, it is 1250 vehicles per hour is correct. Based on the logarithmic or exponential model, it is 1840 is correct. C and D are wrong, you can say. So which options are correct now? Option C, A, B are correct, right? This is your multiple selection question, you can see. right? This is your which one? Multiple selection question we can say, right? Multiple selection question we can say here, right? Like that. Now next question, if you try to write it, what you can write? Geometry design. Identify correct statements. First one, for summit curve, comfort is an important criteria for design. Now second one, for valley curve, comfort is an important criteria for design. Now next one, for summit curve, side distance is an important criteria for design. Next, for transition curve, side distance is an important criteria for design. Okay, like that. If you just observe, in case of comfort, what is the meaning of this comfort? We can say comfort is nothing but which one? Centrifugal force effect. What is the meaning of this comfort? Comfort is nothing but centrifugal force effect, you can say, right? What is that centrifugal force effect? How it will be influencing, if you just observe? When it is a summit curve, just for an example, always centrifugal force is acting in the outward direction of the curve. Which one is outward direction of the curve? If you just observe, your vehicle, let us say it is moving with a velocity v, the centrifugal force will be acting in the upward direction, weight is acting in the downward direction. Now, do we have any difficulty? Do you have any uncomfortable conditions? No. Our weight is acting in the vertically downward direction, centrifugal force is acting in the upward direction. Centrifugal force is acting in the upward direction means what you can say here? We can say that our weight is apparently reducing. If your weight is 75 kg, you feel that you are 25 kg on this summit curve, because weight is in the downward direction, centrifugal force is in the upward direction. You feel that you are lightweight. When you feel lightweight, you will feel uncomfortable. No. When you are lightweight, when you are feeling lightweight, there is no uncomfortable conditions, right? So summit curve comfort is an important criteria for design. Is it an important criteria for design? No need to consider, because there is no effect of centrifugal force, means no need to consider the centrifugal force in the designs. Now second one, for valley curve, the comfort is an important criteria for design. If it is a valley curve, means weight of the vehicle is acting in the downward direction, centrifugal force is also acting in the downward direction, because convexity is there in the downward direction only, or not? Because convexity is there in the downward direction only, centrifugal force also will be acting in the downward direction only. Now what will happen? With your weight, some additional weight is added or not? Yes. How much weight you feel then? If your weight is 25 kg, right? If your weight is 25 kg, you feel that your weight is 125 kg, because centrifugal force is also pulling you in the downward direction, right? So we are feeling uncomfortable or not? Yes, obviously. So in case of valley curve, that comfort or centrifugal force is an important criteria for design. Yes, definitely. Side distance, yes, for any curve, whether it is a summit curve or valley curve, side distance is compulsory. Yes, that is correct, right? Now transition curve, if you just observe, for transition curve, side distance is important criteria. Do you need to consider this side distance for transition curve? No. So what we are considering? Main design of your transition curve is based on what? transition behavior. What is the transition behavior? Gradual introduction of your what? That gradual introduction of what? Centrifugal force, super elevation, extra width and curvature from zero values to full values, right? So that is depending upon which one? Is that depending upon is that depending upon side distance? No, that is not depending upon the side distance, you can say. So D is wrong. So which options are correct now here? B and C options will be the correct one, right? B and C options will be correct, you can say, right? This is your fourth MSQ question, you can say. Now next one. Fifth question will be writing, right? So what is this fifth question? You can say here. Here if you just observe, a traffic stream has which one? A traffic stream has flow rate of 1000 vehicles per hour in a peak hour, right? 1000 vehicles per hour in a peak hour, right? When you considering this peak hour traffic, right? When you are considering this peak hour traffic, what you are having? 1000 vehicles per hour is the peak hour traffic you are having, right? Now next, which one are correct? The peak hour factor, or before going to that, okay, peak hour factor for 5 minutes is equal to, right? Peak hour factor for 5 minutes is equal to what? Peak hour factor for 5 minutes is equal to, right? What is the peak hour factor for 5 minutes? You can say peak hour factor for 5 minutes, how much you can say? Peak hour factor for 5 minutes is so peak hour factor for 5 minutes equal to which one? 0.69 if Q 5 minutes, right? Q 5 minutes is what? 120 vehicles per which one? 5 minutes. So what does it mean? If the peak 5 minute rate in any one of the 5 minutes, right? In any one of the 5 minutes, if you just observe, right? In any one of the 5 minutes, if you just observe, the peak value is 120 vehicles per 5 minutes, then this is a peak hourly factor. Next, if you just observe, peak hourly factor for 10 minutes equal to how much? Peak hourly factor for 10 minutes, how can you get that? We can get this peak hourly factor for 10 minutes as like this, right? How much you'll be getting? Peak hourly factor for 10 minutes is what? Let us take it as now 0.76 if that Q10 is equal to which one? 220 vehicles per what? 10 minutes. C. Peak hourly factor for 5 minutes equal to which one? 0.72 if Q15 equal to, right, 120 vehicles per 15 minutes, like that. D, all are correct. Yeah, good afternoon, Kiteshwar Barik. So now, how can you get this value of peak hourly factor? Anybody remember that formula for peak hourly factor? that peak hourly factor, right? Peak hourly factor for any x minute duration equal to that q actual in the peak hour divided by 60 by x into that qx, peak x minute rate. So here if we just observe for 5 minutes means what is that q actual? 1000 divided by 60 by what? 5 into what? Qx. What is that Q5? You can say 120. What is that value? What is the value? You can say, if you just observe. .694. So this first option is correct or not? Yes, the first option is correct. Now the second option, if you just observe, 1000 divided by 60 by what is that? A 10-minute duration of, so 60 by x means what? 60 by 10 into qx, right? Q10. What is it? Q10? 220. What is the value you can get here? .757 means 0.76, right? 0.76, right? Option B will be correct, you can say, right? Option B is also correct, you can say. So for 15 minutes now, peak hourly factor for 15 minutes equal to how much? 1000 divided by 60 by 15. 60 by 15 into what? What is that? Q15, peak 15 minute, right? 120. So how much it comes to be if you just observe? .083, but what it is given? 0.72, right? It is wrong. So which options are correct exactly? So which options are correct exactly, all of you? Options A and B are correct exactly, right? Options A and B are correct exactly, you can say like that. So is this clear, all of you? Is this clear, all of you? Somebody respond. So peak hourly factor for x minute duration equal to actual flow for the peak hour divided by what? 60 by x times qx, right? 60 by x times which one? Qx, right? Qx means what? That peak rate in that particular peak hour, right? Peak rate in that particular peak hour, you can say, right? Like that. Now, another question, what you can say? Coefficient of friction is coefficient of friction as per IRC is, right? How much is the coefficient of friction? 0.15 if it is lateral, right? If it is lateral friction, 0.35 to 0.4. If it is longitudinal friction, third one if you just observe, sorry, that is B. Option C is what? 0.13 if it is lateral, .3 to 0.4 if it is longitudinal. So which one are correct, all of you now? Subhajit, which one is correct? Lateral friction is how much? .15 is the lateral friction value or not? Yes or no? Coefficient of friction 0.15 is the coefficient of lateral friction, obviously or not? Yes, correct. 0.35 to 0.4 if it is longitudinal, obviously na? Yes or no? Now lateral 0.13 lateral friction 0.13. Are we using this 0.13 lateral friction in highway anywhere? Are we using this 0.13 lateral friction in highway anywhere, or we don't use it? Yes, Subhajit, and we are correct, right? Are we using it anywhere in highway, or we are not using it anywhere in highway? We are not using it anywhere in highway, but in case of airport, but in case of airport, if you just observe, this value will be getting honored. This value will be getting, right? 0.13 is a lateral friction we are using, right? Now 0.3 to 0.4 is also wrong. You can say which option is correct now? Options A and B both are correct. Like that. So is that clear? Yes, now shall I move on to the next question? Shall we move on to the next question? A horizontal curve of radius 200 meters is to be designed okay, a horizontal curve of radius 200 meters is to be designed for its setback distance, right? For its setback distance, right? Let okay, government has given the date of examination on 29th November. Take few classes on the concrete technology estimation. BMC KP sir will take. I don't take because sir is teaching these subjects of BMC now. But materials, concrete technology, that part also will be covered under this building materials, right? That concrete mix design, cement, aggregates, and all those things are covered. Now, estimation and costing I can take. Okay, estimation and costing I can take because the subjects covered by KP sir I should not take now. I will be taking my subjects only. Okay. I'll be taking on the estimation, don't worry, right? I'll be taking on the estimation, right? Don't worry, Subhajit, I'll be taking. But their railways, I have taken many special classes as since you asked, but nobody was attending. That was just a waste of time. But this time, if I'll get students only, I will take these classes. Otherwise, I'll not be taking these classes. Okay, I should get students actually, because one or two people are asking for these classes, but we are taking, but nobody is coming. Nobody is attending the classes. Okay, just inform all your friends and so that they will also attend, then we'll take, right? But we'll take first class. We'll take first class tomorrow or day after tomorrow. We'll plan one class on this estimation and costing. After that we'll go for, okay, we'll see whether we can proceed with those classes or not. We can proceed. Okay, yes, okay, right. We'll just continue this first. Okay, we'll discuss that in group. Okay, Subhajit, we'll discuss that point in group. Okay, I'll raise the same point and then I'll see how many of you are willing to attend, then I'll take. Okay. A horizontal curve of radius 200 meters is to be designed for its setback. Let length of curve equal to which one? Same 200 meters. Length of curve equal to 200 meters. SSD provided is how much? SSD is 120 meters and OSD equal to which one? 400 meters. SSD equal to which one? 120 meters and OSD equal to 400 meters. Then what is the setback? The number of lanes are mentioned in the question or not mentioned in the question, right? Then setback is setback distance from which one? Setback distance from center line of road is Setback distance from center line of road is, right? So here they have given SSD and OSD both are given. So SSD and OSD both are given means how much we have to take it with respect to both we have to take, right? Now equal to 9 meter with respect to SSD. And what is that B you can say? Next option. What is that? Now so now if you just observe, right, you take this OSD as 250 meters, right, not 400, just to take it as 250 meters. Okay, just to take it as 250 meters, right? Now so here length of the curve is given. What is the symbol we are giving for the length of the curve? What is the symbol for this length of the curve? L is the symbol for this length of the curve we are giving. Now let us take equal to 37.5 meters with respect to what? OSD, or equal to 12 meter with respect to SSD and OSD. None of them is correct. So which options are correct? Tell me. Somebody tell me the answer. Which options can be correct here? For this 7th question, which options can be correct? Length is given as 200 meters, SSD is given as 120 meters, and OSD is given as 250 meters. Which options can be correct here? Which options can be correct here? Which options can be correct now? Yes, Subhajit, right? Correct, right? Options A and B can be correct, right? Why these options A and B can be correct? So if you just observe SSD with respect to SSD equal to S equal to 120 meters and L is what? 200 meters. Yes, approximate formula only we can use. So it is which condition? S is lesser than L or L is greater than S, right? Since S is since S is side distance is lesser than L, side distance is lesser than L, then what is the setback distance M you can get? M equal to S square by 8R. So what is that? 120 square by 8 into what is that radius you can get? 200. Then it will be equal to 9 meters. So with respect to that SSD it is correct only or not? Yes, with respect to SSD it will be correct only. First option is correct. Now when you are taking the OSD equal to S equal to how much? 250 meters and L equal to how much? 200 meters. So which one is higher? L is greater than S na? L is greater than S or L is lesser than S, right? L is lesser than S or S is greater than L. Then how can you write the setback formula? L into 2S minus L by 8R. What is that L? 200 into 2 into 250 minus 200 divided by 8 into 200. So how much it comes to be? 37.5 meter it comes to be. 37.5 meter it comes to be, right? Option B is correct, right? So C and D can be wrong, you can say like that. So is that clear? So is that clear, everyone? Are you getting 39? Two into 250 minus, I am getting 37.5, right? I am getting 37.5, just observe, right? That the calculation 37.5 is showing for me. So which options are correct? A and B are correct. Yes, A and B can be correct, right? But if you are using that S square by 8R, can we use that S square by 8R? If you are using that M equal to S square by 8R, we'll be getting 39.06. But can we use that S square by 8R formula? No. For this length, side distance greater than the length, right? For side distance greater than the length of the curve, s square by 8r is not applicable. Which one? For side distance lesser than the length, which one is applicable? S square by 8r is only applicable. For side distance greater than the length, which one is applicable? For side distance greater than the length, which one is applicable? L into 2s minus L by 8r is only applicable. Yes, na? So these formulas you have to be careful with, right? These formulas you have to be careful with, right? Like that. With respect to SSD, it is S lesser than L. With respect to OSD, it is S greater than L, you can say, right? It is S greater than L, you can say, right? Like that. Now, I'll be moving on to the next question. A summit curve is formed by, right? A summit curve is formed by two gradients plus 4%, or I'll write like this, you can say. Plus 1 in 25 and minus which one? And minus 1 in 20 gradients. One in 20 gradients, you can say, right? Gradients, let us say like this, right? Now, here SSD equal to which one? What is that SSD, you can say? That SSD on the curve is equal to 80 meters. Okay. Capital H, height of the driver's eye, right? Height of the driver's eye is equal to how much? The height of the driver's eye is equal to 1.2 meters. Height of the object small h equal to 0.15 meters. Then which of the following, right? Then which one is correct, right? So what you can say now? So here what kind of questions may be asked here? What kind of questions may be asked here if you just observe? What kind of questions may be asked here if you just observe? On length there might be a question or not? Yes, right? So options may be given like this. The length of summit curve is equal to 131 meters. B. Length of summit curve is equal to which one? Length of summit curve is equal to which one? How much you may be getting here? 111.11 meters. Then what you can say? What is another type of options can be given? Length corresponding to length, some options may be given, right? Corresponding to length, some options may be given, and corresponding to what? And corresponding to the highest point, and these things they will be given or not? Yes or no? Location of which one? Highest point from flatter gradient equal to, right? So which one is a flatter gradient, you can say here now? Which one is a flatter gradient? 1 in 25 means 4%, 1 in 20 means 5%, 20% is a flatter gradient, right? So 20%, 1 in 25 is the flatter gradient, you can say, right? 1 in 25 is a flatter gradient, you can say now, right? Like that. So how much you can be getting here? It is equal to 58.22 meters, or location of highest point from the flatter gradient equal to how much? We can say? How much you can say? .38 meters. So which options are correct, Subhajit? Yes. 131 for SSD, correct, right? 131 for SSD, correct, right? When SSD is given, how to calculate the length if you just observe? When SSD is given, how to calculate the length, you can say now? When SSD is given, how to calculate the length, you can say? SSD is given. How can you calculate this? Which formula we have to use for SSD? Which formula we have to use for the calculation of length of summit curve based on SSD? Yes, which formula we have to use? Let SC is lesser than LE or LE is greater than S, right? When you are assuming that, what is that L, you can say NS square by 4.4 or not. When it is for SSD, yes, option A and C are correct, Subhajit, right? Whenever it is, yes, NS square by 4.4. What is that N, you can say now? That net deflection angle N equal to what? This N1. What is that N1, you can say here? That N1 equal to 1 in 25 means what? 4%. And N2 equal to which one? 1 in 20%. That 1 in 20, that is equal to 5%. Therefore, net deflection angle is what? N1. So plus 4 minus of which one? Minus 5. So total how much it comes to be? 9%. 0.09 is the net deflection angle. So 0.09 into S is how much? 80 meters. 80 square divided by 4.4. How much you will be getting now? 131 meters you are getting. So obviously option A is correct, option B is wrong. Now location of the highest point from the flatter gradient. Flatter gradient means 4% is the flatter gradient. So 4% is the flatter gradient means from first tangent point or second. Tell me. This is your 4%. This is your 5%. So from which one? From flatter gradient means what? X1. What is that X1? N1 by N into L. What is that N1? 4% by 9% into which one? L 131. So how much will be getting? 58.22 meters will be getting here. Okay. Now which option is correct? Option C is correct and option D will be wrong, you can say. Like that. No. There is one more question from traffic. Yes, correct, right? Anant Vivedi, thank you. If you're understanding, that is important for me. If the students are understanding or not is important for me. Yes, if you are getting, I'm happy, right? Which of the following models are not single regime models? Which of the following models are not which one? Single regime models, right? What is that? First, if you just observe the different models given, which models? Single regime, double regime, single regime, two regime, three regime models means two different variations, two regime, right? One variation only, one regime model, you can say, right? What is that first one, you can say? Green shield model. Next one is which one? What is that? Next one you can say? Daganzo model. Green shield model. Daganzo model. What are the different other models we are having now if we just observe? Smulders model. Okay, Smulders model, right? So what are the other models we are having? Mainly you can say there are many types of models we are having or not? Yes, obviously there are many types of models we are having, and among them what is next model? You can say Smulders model. This is your Smulders model, and what is next one? You can say What is next one we can expect here? What are the other models we can have? Anybody name the models? Daganzo model. Okay, pipes model is there. Okay, right. That is also pipes model. Next, I'll write one more option only. I'll write this one more option only. What is another model I can write? Daganzo, Smulders, pipes model, and what is that? Greenberg model. So tell me, if it is a green shield model, how it will be? When it is a green shield model, means this is your speed density relation. How the speed density relation will be? This is linear, same variation only we are having, right? Same variation only we are having throughout. Now tell me, okay, like that many models are there, right? Like that many models are there. Ramana Reddy, okay, Dwarak, good evening. Sorry, good afternoon. How are you? So this is a linear model or not? Green shield model is a linear model, and it is a single regime model or two regime model, you can say. Single variation only we are having throughout, means it is a single regime model, right? Same variation throughout we are having. Do you have any changes in the variations? There are no changes in the variations we are having, right? Daganzo model means what? How the Daganzo model will be? Speed density relationship, if you just observe, the Daganzo model will be like this. When it is a Daganzo model means, when it is a Daganzo model, speed and density are having only one relation or two different relations they are having? Speed and density are having only one relation or two different relations we are having, right? Which one? Two different relations they are having. No, yes, no, two different relations they are having, right? Two different relations they are having, right? Like that. So two different relations means it is a two regime model, right? This is your single regime model. This is which one? Two regime model. Smulders model. Smulders model, if you just observe, what is the Smulders model? You can say speed density relation for the Smulders model is what? Just a modification of this Daganzo model. It will come like this and it is like this. Sorry, just a minute, I'll write it again. Like this. Okay, that straight horizontal line will become inclined line, you can say, right? So this is also which one? Two regime model. Two variations are there. And if it is a pipes generalized model, what is that equation for pipes generalized model, if you just observe? Yes, right. Only this will become which one? This horizontal will become inclined, right? Smulders model is a type of Daganzo model only. In case of this Daganzo model, that in the starting portion it is horizontal straight, but in the Smulders model, the horizontal straight will become which one? Linear variation, right? There is no variation, constant, but here linear variation, right? Linear variation you are having. What is that V? You can say V equal to Vf into 1 minus K by Kj power n, you can say. What is the meaning of this n? Any power you can take it. Power 1, power 2, power 3, power 4 means only single variation you are having or varying variations. If you are substituting n equal to 1, it will become green shield model or linear model. Green shield model or linear model is a type of pipes generalized model or not? Yes. So it is also what? Single regime model only. It is also which one? Single regime model only, you can say, right? Now the Greenberg model. What is the meaning of this Greenberg model? Greenberg model equation is what? Logarithmic model V equal to Vf into which one? Log Kj by K to the base e. So this is also which one? Single variation. That is, the variation is with respect to logarithmic function we are having like this. Okay, this is V, this is K. So it is also which one? One regime model. So which options are correct? Which options are correct now? Tell me. B and C are only correct, right? B and C are only correct, right? D, pipes generalized model is not the double regime model, two regime model. It is only a single regime model, right? It is only which one? It is only a single regime model, right? Why it is only a single regime model, you can say? Because the same variation only you are having or not. That power n, if you substitute n equal to 1, throughout the curve, it is same power 2 only. Throughout the curve, it is power 1 only. Throughout the curve, or power 3 only. Therefore, what will happen? Single regime model only you are having on that. Yes. So Smulders model and Dagan's model, right? These two are taken as which one? These two are taken as which one? These two will be taken as what? The two regime models, you can say. So is that clear? Shall we move on to the last question for today? Shall we move on to the last question? B and C are correct, right? Yes or no? B and C only will be correct now, right? So D is not correct, right? D is not the two regime model. Okay. Now, question number 10. Question number 10, if you just observe. Which of the following statements are correct? How much it will be? Okay. So what are the, you can say, first option? For highway only I am telling. Grade compensation can be applied for any gradient when associated with curve. Second one. Okay. So what is that second statement? Camber for WBM in heavy rainfall is 3%. Next, C value is what? Tests on the shape tests on aggregates, or I'll just change it otherwise. Flakiness test will be followed by elongation test always. Elongation test on aggregates always. Next. So flakiness test will be followed by which one? Elongation test always, right? Elongation test always, right? While designing expansion and contraction joints, the temperatures will be compared with what? Construction temperature only. like that. So now these are the options. So which options you can say here, all of you? Grade compensation can be applied for any gradient when the gradient is associated with curve. Is it for any gradient as per IRC, or it can be applied only for gradients greater than 4%? Can you apply this grade compensation for gradients lesser than 4? No. As per IRC, grade compensation should not be applied for gradients associated with curve when these values are lesser than or equal to 4. But if it is a railway, you can apply for what? Any gradient or not? Yes, but it is highway means you can apply grade compensation only for gradients greater than 4, not for up to 4. Okay. Camber for W beam in the heavy rainfall is 3%. Correct or not? Yes. B is correct or not? Camber values, how to remember? 1.72%, 2 and 2.5, 2.5 and 3, 3, 4. 1.72, 2, 2.5, 2.53, 3, 4. So for CC pavement and high bituminous 1.72. Thin bituminous 2.5. W beam and gravel 2.53. 2.5 is for light rainfall, 3 is for heavy rainfall. So heavy rainfall means it is 3% is correct only. Now, flakiness test will be followed by elongation test on aggregates always. First, which test we have to conduct? First, which test we are conducting? Flakiness index will be calculating or elongation index will be calculating. Do you remember the sequence of test always? First flakiness test. After that only we are going for which one? Elongation test, right? First we don't go for elongation test. First we'll be going for flakiness test only. Is it not? This is also correct now. Listen, the sequence of this test I have mentioned also, if you remember. Now, while designing expansion and contraction joints, the temperatures will be compared with the construction temperature only. Yes, correct. If you wanted to design the expansion joints, what we need to do? Expansion joints will be taking care of expansion. The expansion is due to which one? Rise in temperature with respect to construction temperature. So, with respect to construction temperature only. Now, after that, if it is a contraction joint means what? If it is a contraction joint means what? They will be taking care of contraction. What is the meaning of this contraction? Fall in temperature with respect to what? Construction temperature only. So that is also correct or not? Yes. Which options are correct now? B, C and D options will be correct. You can say, right? B, C and D options will be correct. You can say, right? Like that. So is that clear all of you now? Anyone having any doubts? Yes, no? So again I am telling there is a price hike. Yeah, highway materials part, that part is not covered. So don't worry, I'll be just, this crash course is coming now. So that, which one? Marshall stability test I have covered in special class. That soil test also I have covered in special class, right? Only that bitumen and the aggregates I did not cover there, right? Only the bitumen and aggregate we are left actually. We did not cover. Okay? Don't worry, those, the crash course is coming again now. In that crash course, we'll be covering those tests. Okay? In that crash course, we'll be covering those tests. Don't worry. Okay? Don't worry. Or in special classes also I may be taking further, right? Because the crash course is coming, I did not focus on the special classes on this bitumen and aggregate. Okay? Like that. So there is a price hike alert. Inform your juniors, friends, those who are willing to subscribe for the plus courses. Tell them to subscribe by today itself, because today midnight onwards the prices are going to be increased for the plus subscription. Okay, you have to be careful. Yes, see, first flakiness test will be followed by elongation test means what? First, which test we are conducting? The sequence of test recommended by IRC is what? First, flakiness index only, right? Flakiness index will be calculating. Then we are going for the elongation index. So while defining that elongation index value, if you remember, what you will be doing? Elongation index equal to weight of the material because there are new students also will be coming now. The new students also will be participating now. So when new students also will be participating, I cannot take like that, or I'll take special classes, right? Just within 2 days I'll be completing them. That is better, I think so, right? That is better, I think so, right? I'll take special classes for that, then that would be better. Okay, don't worry. Now, so first flaky, suppose if you are taking a 2 kg, if you are taking a 2 kg material and just throw this a thickness gauge, right? What you are having, there is a thickness gauge you are having now, the slot sizes, all these things we know. And first we will be calculating which one, the material passing through this, right? Material passing is which one, 200 grams, out of which one, total 2000 kg. Means, so what is that flakiness index? You can say flaky means what, the thinner part. How much is the thinner part? You can say here thinner part means material passing or material retaining. Thinner aggregates means materials passing, right? When they are thinner, very thinner, then only they will pass, right? So 200 divided by which one, 2000 into 100. How much is that flakiness index now? 10% like this. Now when you are going for this elongation test, what you are doing, this is your length gauge, or this is your length gauge, you can say, and we have to pass this material aggregates along the length of this one only. We have to pass them along the thickness of this material only, you have to say, right? So here elongated material, elongation index means what, elongated means what, retained amount we have to consider, right? What is the retained amount? Let us say 180 grams or 360 grams, let us say. Okay, yeah, 360 grams. Okay, it is, let us say 360 grams, right? Now here when you are calculating the elongation index, that weight retained is 360 grams divided by which weight we have to take, the total 2000 grams weight we have to take, the total 2000 grams weight we have to take, or 1800 only we have to take, 1800 only we have to take, right? So this is which one, 20%. So what is that elongation index? You can say weight retained divided by weight total after eliminating flaky material. So after eliminating flaky material means first which test is to be conducted? Subhajit, now your statement comes into picture. After eliminating flaky material means, this flaky material means which is passing through the thickness gauge, 200 grams out of 2000, 200 grams is eliminated means on the remaining 1800 grams only we have to conduct this one, right? So means which test should come first? Which test should come first? According to the definitions given for the flakiness index and elongation index, which test should come first? Flakiness test or elongation test will come first? Flakiness test or elongation test will come first? Which one will come first? Subhajit, flakiness test will come first or elongation test will come first? Flakiness test will come first, and it will be followed by which one? It will be followed by elongation test, right? It will be followed by elongation test, right? Yes, sir. It will be followed by elongation test means what? Next test after the flakiness test will be elongation test. So is that statement clear now, Subhajit? Is this okay now, statement? Is this okay now? Right? Yeah. What is the meaning of the statement? Followed by, yes or no? Flakiness is followed by elongation means what? Flakiness is followed by elongation means what? Suppose if I'll say RPSR is following KPSR. What is the meaning of this one? RPSR or A is following B. A is following B means what? A first, B second, right? A is following, A is followed by B means what? A is followed by B means what? If you will say A is followed by B means what? A first, behind the A, B will be there, right? A first and behind the A, B will be there. A is followed by B means what? A first, B second. So here also flakiness is followed by elongation means what? Flakiness first, elongation second, right? Flakiness first, elongation second, like that. That is simple English only. There is nothing new here. Okay, that is simple English only. Okay, is that clear, Subhajit? So this is my contact number. Those who are willing to subscribe for the plus courses, you can just contact me at this number regarding any queries. Okay, these are all the subjects I'll be taking on Unacademy Plus platform. These are the advantages when you are using the code RP Civil and subscribing for the plus courses. Thank you all of you. Have a nice day. We'll be closing the session. Again, day after tomorrow, we'll be meeting with MSQs on railway engineering. Okay. Thank you all of you. Have a nice day.